So the counterbore that we're working on, it's hard to see it, but there's actually a thrust bearing inside there. So this is what we're going to be cutting. I'm going to start, this is my plan of attack. We're going to start with the shell mill right here. This is going to get it pretty close to size. We'll get this mounted on this shell mill holder right there. I had to make a custom washer and a bolt so that I can get that held on there properly. So we'll get that on there and get it tightened up. So this is what'll kind of rough it out, and then we'll have a little bit. We still got a bore, and after that we're going to mount up this Criterion boring head with a boring bar, and we'll finish it out like that. All right, we'll see if we can get the cutter touched off. I went ahead and brought it in very gently until it touched, just like that right there. So that feels like that cutter's touching, and I've got the DRO set to a 0 right there, so I can see about how far away I am. Running 60 surface feet a minute. We're going to use the paper just to verify our touch off here. All right, it pulled it out on -1 thousandths. All right, that's -3. I'm going to set a 0. I think it's touching. I'm going to bring it back and look. Oh yeah, touching. All right, I'm going to feed this by hand a little just to see how the machine and everything is going to react. I can see some things kind of moving around a little bit. I'm going to go ahead and relock the table here really well. Let's see if that'll help some. Come back in. Yeah, I'm just going to be doing this by hand. I'm afraid if I power feed this thing, something's going to give. 100 thousandths. I'm going to back out and see what's happening here. Doesn't look too bad. We'll keep her going. We got about 100 thousandths to go. I'm going to go ahead and check the depth here. On the DRO, I went a little bit shy. .383. My DRO, I went 380. I knew it was going to fluctuate a little bit. All right, 383 is the depth that we got there. I'm going to go ahead and just take it to 400. And when we come in here and counterbore it, we'll just touch our tool off there on our what we've already counterbored, because we don't have a whole lot to come out of there. Just going to do about another 15 thousandths. All right, that one's showing about 3 thousandths. Three thousandths to 0.4 is what and that one's 3.5. So that's going to be good enough. There's this is the depth that the counterbore, the thrust bearing. So you got a washer on each side of the thrust bearing that goes in there, and it'll just pretty much be flush with this outside. And then the spindle, the meatball section of the handle, is going to pull right up against the bearing. It's never going to touch any of this out there. So they've got it, he said he's got it designed so that it's just proud of this face right there. So I'm happy with that. We can use our boring head and come in here and we can just touch this face, and we'll set a 0. When we counterbore it to finish it out, we'll just go to that 0 on our DRO every time. And there'll be a line in there, but you'll never know it because the thrust bearing will be in there. Well, our roughed out counterbore looks pretty good. The shell mill did a good job, so we're going to go ahead and remove this now. We'll put a collet chuck in here. I've got a Criterion boring head that we'll use, and a little short stubby boring bar. I got a hand grind a tool bit, and we'll get in there and we'll finish this diameter out. We're going to have to move the workpiece down in order to install, and whenever we're taking our measurements. That's going to be the boring head that we're using. Got a little short stubby drill, and then, a short stubby boring bar. And this is a high-speed steel bit that I ground up. My big spanner wrench that I used to tighten this collet chuck, I forgot that I had broken it when I was trying to take apart one of them hydraulic cylinders, so I'm having to use this smaller one, but it's still getting the job done. So I've gotten to a point where I realized that there's been a mistake made somewhere along the way. I have not had the thrust bearing here with me. It's been at the new shop in a box ever since I got it. It's just been put up, and I've been working off of prints that were provided to me. And I had to go to the shop yesterday and get a few things, and I grabbed these parts while I was there. And this is the first time I pulled them out of the box. And as soon as I pulled it out of the box, I realized that something's not adding up here. So we've already got our counterbore larger than the thrust bearing diameter there. And what doesn't make any sense is that the dimension that I was boring this to is on the print that was provided. So after realizing this, I've sent an email over to Fireball and trying to find out what's going on here on why the print actually says 2.344 inches, this counterbore, by 0.4 deep. The depth is right. I can see that the face of the washer here is just proud of this face that we machined here, so that's right, but our diameter is wrong, and I don't know why. In the email, I asked is there a different thrust bearing that's being used for the USA version? Because remember, we're making the USA made version, and the Taiwan version is made in Taiwan. So I don't know if there's a difference in parts that I'm not aware of yet, so I'm waiting to hear from Fireball Tools on what's going on right here. So it's not the end of the world. We can fix this. I just hate that we're having to fix something that's supposed to be brand new. And I hate making mistakes on these brand new parts like this. We've already made a mistake on the jaw there. That was my fault, only my fault. This right here is confusing as to what's going on right here. So I want to see what they have to say about this, is if there's another bearing that fits here that we should be getting, or what's going on. But what we could do, I'm going to wait to hear from them on what's going on here. But what we can do is go ahead and clean this bore up with the board head like we were about to do, and machine a sleeve and just press a sleeve in there to bring it down to it just needs enough diametrical clearance for that just to kind of slide in there. So we can sleeve it, but I want to find out, are we boring it to a different size thrust bearing? That's what I want to find out. So I'm going to hold off on this for right now until I get that information, and when we do, I will let you know how we're going to proceed. All right, I haven't heard back from anyone yet, and I'd like to keep moving on this job right here. So what I've decided to do, we're going to proceed using our boring head just to clean this up round. So the hole measures, or the counterbore measures, 2.180. And I want to just clean it up. That way I make sure it's round and we got a good size there. Because I got a feeling that what I'm going to end up having to do here is just machine a sleeve and press it in there and use the thrust bearings that we have. And if I need to, I will set this back up and line it up and counterbore again if just so happens there's a different thrust bearing that needs to be sent to me. But I don't see there being another thrust bearing that's larger in diameter like that we should use, because the diameter of the thrust washer matches up with the spindle out here, okay? So let's just clean this up and we'll leave it at that. Maybe by then I'll hear from someone over at Fireball on what's going on with this. But after we get this done, if no more changes are needed until then we'll go ahead and flip it around and proceed on our drilling and tapping that we need to do for our bolt-on jaws. I'm going to get that tool touched off on that bore. So the only way that you can spin these spindles here is to have the machine off, put it in the highest gear it has, which is 2000, and then turn the machine off, and then that hydraulic pressure releases and you can spin it. So I'm just going to go ahead and work on getting this tool set, and it is still locked. Usually I just rock it like that until you just feel the tool or see it touching. There it is right there. All right. Brought the table in using the Y-axis and just felt it until it touched that shoulder back there, and we set a 0. So that should be good enough for what we're going to do. I'll stop it just a few thousandths shy of that 0 mark there. All right, so let's go ahead and let's just give it 5 thou and see how it cleans it up. About like that there. All right, guys, I think we have this counterbore issue figured out. I was able to talk to Jason at Fireball Tools to kind of figure out what was going on right here, and we've got it figured out. So whenever Jason had sent me those prints, just some basic prints so I would know what to machine this stuff to, the one that he sent me for this right here was actually an older print from, I guess maybe an earlier design, and the thrust bearing that they had originally started using was larger than the ones that they're using now. So that's what the problem is. This thrust bearing that is going in there is the current thrust bearing that's used in these vices. So it was just the wrong print. Not a big deal, okay? Because we're gonna be able to fix this, especially with what I had planned to do anyway. So all we got to do right here is skin about 20 thousandths out of that, and that is going to fit a thrust bearing for an 1¼ bore thrust bearing. What I had planned on doing after I get through machining all these parts and getting this vise built, after that I wanted to actually revisit this and build my own spindle for this vise. Okay, so this is the one that comes in the Hardtail Vise. All right, this is the one that Fireball Tool makes. And I would like to replicate this, but build it myself. But this is a 30 millimeter rolled thread, Acme thread, and I don't want to make it metric. I want to use imperial. So the next closest size up from this is 1¼ 5. It's nearly identical to this now. This is just slightly smaller in diameter. So since I'm going to end up building my own spindle for this, and it's going to be 1¼ we really need to bore that so it's going to fit an 1¼ thrust bearing. So that kind of worked out in my favor. I went to McMaster-Carr, and Jason looked too, and we both kind of decided this would be a perfect bearing right here. This is off the McMaster-Carr website. So it's a nice thrust bearing for an 1¼ rod. And the OD is 2.198 inches. So where it's at right now, we've actually only got about 20 thousandths to skin out of that. So my plan is to go ahead and skin this out so that it fits this thrust bearing, which I actually have on order now. And then what we'll do is machine a sleeve that'll fit in there. We'll just make a slit fit sleeve that'll fit the thrust bearing that they provided, and that'll work just fine. There's going to be nothing wrong with that. And then when the day comes that I go ahead and machine the new spindle, we'll simply be able to just pull that sleeve out, and our other thrust bearing will fit it. And I'll make sure that it fits because I got it on order. It'll be here in a couple of days, and we'll be able to test fit it. And it just needs to be a just simple slip fit. It doesn't need to be tight or anything like that. So we'll go ahead and counterbore this so that I know that this bearing will slide in there. We'll give it a few thousandths clearance, you know. And I think that's going to be a perfectly suitable fix for our issue at hand right here. So luckily we didn't do anything bad, and we're going to be able to continue with this. So we're going to go ahead and get this thing counterbored now. All right, let's get to making a cut. I added a dial indicator over here so I could see my depth. I'm going to reset this to a 0 because now my DRO has shut off not once but twice on me now. So I guess that's going to be another problem that I got to deal with. If you get a 0 set on DR, it shuts off and you lose its place. But that DRO, whenever it turns its power off, you lose all the data that's in it. It's just a really old unit. So anyway, I think we're ready to go now. Really not taking much. I only dialed in 5 thousandths here. So it's just going to true it up, and then we'll mic it and just make one more cut. So that's a 100th thou. All right, looks like we're touching the back there now. Reset our DRO to 0. And I'm going to reset this dial indicator over here to a 0 for a stop position. Looks good. Use our telescope gauge and a 2 to 3 mic. All right, so I'm getting a 2.190 measurement right there. So we've got a good 10 thousandths to come out of there. That should have been 2.2 on our size there, so we'll give it a check and see. All right, let's see what we got. Looks like I finished out 2 thousandths over. So we're good to go on that bore. So I think what we'll do, I'm gonna flip that tool around and we'll come in there and just break that edge off. Basically do a chamfer. Probably good to do that inside one there as well. All right, so technically our counterbore is finished. All right, it looks good. It's got a nice finish in there. When I'm using a mirror, I could see this side of this smaller hole here, and it was just barely starting to touch that. I didn't see that it was cutting into the hole more over on that side, but ain't no big deal. There's plenty of clearance in there, so it's not going to rub or anything. All right, well, that certainly looks good. So this end of the vise there is the dynamic jaw is done. So now we can go ahead and move on to our 2 tapped holes up here on the top part of the jaw that we need to do.